Very good morning, viewers. Myself, Dr. M.H. Channaya, and in today's video, we are going to learn about the development of lateral surface of a cone. Friends, you know very well, the cone will have a base and it will be connected to this apex. This is how it looks, and it will have the radius of the base r and the length of the generator, n generator, as r, and the height, it will have some height like h. So friends, this cone has got a curved periphery. It doesn't have any straight edges either for the base or for the slant surface. Hence friends, for getting the points on the development, we are going to divide the base of the cone with some number of equal parts. It will be generally minimum 8 and may go up to 12 parts. So friends, whenever you place any of these cones on HP, what happens when you look from the top, you will be able to see the base of that. It is something like this. So you will be able to see in the top view a circle for the base, and in the front view you are going to get a circle, a triangle which is isosceles in nature. So in today's question, he says there is a cone of diameter of base 50 mm and axis 70 mm long is resting on HP. So friends, whatever may be the given position, this cone will always have the top view a circle and front view a triangle which is isosceles in nature. Similarly friends, whenever you are placing a cylinder on HP, the top is going to be a circle and front view a rectangle to the given height. So in today's video, I am going to place this cone on HP, obtain the top and front views of the cone. So friends, the top view is going to be a circle of the given diameter. The diameter is given to be 50 mm. That means it's going to have a diameter 50 mm, and I am going to divide this into 8 equal parts. How to divide? You draw a vertical line and a horizontal line. The circle gets divided into 4 equal parts. Again, draw 2 more lines perpendicular to each other, and this you will get as 8 parts totally. All these will have equal angle, and we can mark this dimension, the diameter, as 550. 5 indicates diameter, and this is 50 millimeter dia we have got. So I show it as 550. So friends, let us name these points of division as A, B, C, D, E, F, G, H. So these are the division points. We will mark O, the apex of the cone. This sharp point is called the apex in case of cones, and for the pyramids we call that point as vertex. So friends, let us see what do we see in the front view. Very obviously, the front view is going to be a triangle. So I will just project all these points. So on this will lie the point A dash, here point E dash on XY. Likewise, on this vertical line drawn through B, you will have B and H. So B dash, H dash. This is CG, C dash, G dash, and this is the point D dash, F dash. So we'll mark the points later on. Let us draw a vertical line through this point O and mark the height. Height is given to be 70 mm. So friends, I am going to mark this as O dash, and the height given is 70 mm. So to construct the top and front view, we need to have the diameter of the base and the height. Friends, let us join this apex to all these corners on the base. That is to say, we are going to join the point O to A, O to B and H by thin line, O to C and F, finally O to E. So friends, we will mark this as D dash F dash, D dash F dash, C dash, G dash, C and G, and BH, B dash H dash. Friend, this is how the cone looks in the front view when it is resting on its base on HP. Friends, now we are required to draw the development of the cone. So before that, let us see what are the lengths of the generators. Friends, if you observe this front view, O dash E dash represents one of the end generators of the cone. So in pyramid is called as straight edges, and here we have nothing like edges. So the last line is called an end generator. Likewise, O dash A dash is also another end generator. And when you are making this drawing, you will have to show only border line, that is O dash A dash, A dash E dash, E dash O dash by doctrine, remaining all to be shown by very thin lines just visible. That's all. Friends, now to draw the development, we have got a formula to be remembered by the student, and we say the included angle or the sector angle. I will tell you what it is. The sector angle is represented by theta, and theta is given by the formula 360 degrees into R by R. This has to be remembered by the students. So friends, what is this R and what is capital R? Friends, R stands for the radius of the base. So if the diameter is D, radius equal to D by 2. I will say here R is equal to D by 2. That is 50 by 2. Works out to 25 mm. Then comes R, capital R. Friends, capital R stands for the length of the end generator. That is capital R equal to length of generator. Length of generator or end generator is again a true length. This is a true length TL. So which is that length? It is O dash E dash. O dash E dash. Friends, this I will mark here as R. So how do you obtain this R? So this R can be measured or obtained only after construction of this triangle O dash, A dash, E dash. You can keep the scale and see what the length R is. That is the length of the end generator or the strand generator. Friends, say we are going to calculate this. Say this is 360 multiplied by R is 25 mm divided by capital R. Say it works out to 70. So say this works out to 120. I have not calculated. So you have to calculate the actual value and get that angle theta. So friends, after you get that angle theta, let us see how to go ahead with the development of this cone. Friends, here in the question it says, the cone resting on its base on HP is cut by a section plane which is inclined at 30 degrees to HP. See, when it is inclined like this, very obviously it will be normal to VP. So whenever a section plane is normal to VP and inclined to HP, it is seen as a line in the front view. And where does it pass through? The section plane is inclined at 30 degrees to HP, bisects the axis of the cone. So axis of the cone is O dash O1 dash. Mark the center point of that at a height of 35 millimeter. Say this is half of the height, 35 mm, and the section plane is passing through that point. So friends, I am going to write a line here. This line, I will call it as section plane SS, is at an angle of 30 degrees to the horizontal, and it is cutting the slant generators of the cone. It is not touching the base of the cone. So, to draw the development, he is asking us draw the development of the lateral surface of the lower part of the cone. This is the cone. The section plane is cutting like this. We are going to throw away the upper part and we are left with the bottom part. So that bottom part of the cone is to be shown by dark lines. And again here, these have to be shown by thin lines. Friends, the section plane SS is cutting OA. It is cutting OB and OH, C and G. It is also cutting DF, and finally it is cutting O dash E dash. Friends, there are 8 generators totally, because we divide the circle into 8 equal parts. So you will have 8 points on the curve. So now friends, to obtain the development, here we are going to make use of the true length R. This R is the true length. So friends, I will just write a line. It could be vertical or inclined, doesn't matter. I am going to write a line here of length is equal to R. This is R, which is the true length. This is O, the apex. And here friends, I am going to mark the angle with this as the base. That's the angle we have calculated as 120 degree. Suppose say this is theta, which is equal to 120 degrees. We have calculated based on r and small r. So we will draw an arc through this. So friends, this is how the development of the cone appears like this. It is going to appear like this, and this has got a length r on both the sides. I will call this as r, and this r is obtained from the front view of the figure, and this angle we have calculated using the formula theta. The subtended angle is equal to small r by capital R into 360. I have shown the calculation already, and here friends, I am going to divide this into how many? 8 equal parts. So if you write a line here through this gets divided into 2 parts. Again, a center line here, a line here. This has got divided into 4 equal parts, 1, 2, 3, 4. Further divide that angle equally. So you will have totally 8 divisions on this curved periphery. Now friends, to draw the development, you can see similar to our pyramids and prisms, all these generators are cut by the section plane. The base of the solid is not touched by the section plane. Hence, we are going to have the complete base, and this complete base is this line. So before that, let us mark the points in the development. Let us say this is A I am starting with, this is B, C, D, E, F, G, H, and again A, because OA should be there in the development on both the sides. Now friends, let us start the points where the section plane is cutting the generators. Friends, generator O dash A dash is cut here. O dash A dash is inclined to HP, but it's parallel to VP. So this gives you the true length directly. So from A, we can take this measurement and mark here straight. This is one point. Similarly, on the other end of OA, you will have, so this point is over. Next, OB and OH are cut here, but OB and OH are not true length in nature. So that has to be shifted to one of the true length. It could be to the right or to the left. So say I am going to shift that to the right side and obtain a point. So this distance I am going to mark on OB and OH, little above that. So OB, OH. We got 2 points. Then friends, OC and OG are cut here. OC and OG are not true length. So that I am shifting to this and I obtain the true length of that. Here on the last generator, mark on OC, OG, little further. OC and OG. Next comes friends, OD and OF are cut here. OD and OF are not true length again. So shift that to the last line, mark on OD and OF, little up. Finally friends, the last generator or the end generator O dash E dash is cut here. This is the true length, or so directly mark that on the generator OE. Friends, you have got 1, 2, 3, 4, 5, 6, 7, 8, 9. See, 1, 2, 3, 4, 5, 6, 7, 8. 8 points because there are 8 generators. So, for all the cones and cylinders, the points so obtained are to be joined by a smooth continuous curve. So, friends, I am going to join this like this by a curve. So, this is how I am going to join, and the portion below this curve is visible or retained. So, this arc I am drawing is for the base which is intact, and the portion from here to here is retained. And friends, this is how we obtain the development of the part P, that is the lower part, that is development of P. P is the lower part of the cone. Friends, here remember these lines here to here, these lines are all just imaginary lines, and we have to show them by thin lines, and only the periphery, this should be a continuous curve, this should be an arc. Friends, I hope the presentation was interesting, and if you like this video, do share with all your friends. Have a nice day.